Scientists used to ask a simple question, are we alone? Now the question sounds very different. Why are the signals getting stronger? That shift did not happen by accident. It happened because something changed quietly, gradually. Then all at once, a growing number of serious scientists are starting to admit something unsettling, not in headlines, not in bold claims, but in careful words hidden inside research papers, interviews, and late-night discussions. Among them is Brian Greene, who has openly spoken about the rising probability that life beyond Earth may not just exist, but may be closer than we once believed. For decades, the idea of aliens lived in the world of movies and speculation. It was treated as entertainment, not science. If someone talked about signals from space or strange objects in the sky, they were often ignored, sometimes even ridiculed. But that attitude is changing, not because of belief, because of data. In the last few years, scientists have detected things they cannot easily explain, signals that repeat with strange precision, objects that move in ways that challenge known physics, planets that look more like Earth than anyone expected, and atmospheres filled with chemicals that should not exist without life. These are not theories. These are observations. Most people still think the search for alien life means pointing a telescope into deep space and hoping for a lucky discovery. But the truth is more surprising. The search is already producing results, not clear answers, but strong hints. Enough to make scientists pause, enough to make them rethink everything. And here's a part that most people do not know. Some of the strongest clues are not coming from the edge of the universe. They are coming from relatively close by, from within our own galaxy, even from within our own galaxy, even from within our own cosmic neighborhood. That changes the story completely. Because if life exists far away, it is interesting. But if signs of life are getting closer, it becomes something else entirely. It becomes urgent. It becomes real. There are signals that arrive in bursts. They last for milliseconds. They last for milliseconds. Then they vanish. Some repeat in patterns that feel almost intentional. Scientists still argue about their origin, natural or artificial. No one knows for sure. They're objects that enter our solar system from interstellar space. One of them behaved in a way that no known comet or asteroid should. It accelerated without a clear reason. It left no visible trail. It did not follow the rules. There are planets orbiting distant stars with atmospheres that contain water vapor, methane, and carbon compounds. On Earth, these are often linked to life. Finding them elsewhere raises difficult questions, questions that science cannot ignore anymore. And then there is the silence. A universe this vast should be full of signals, full of noise, full of activity. Yet what we hear is mostly quiet. That silence has a name, a paradox that has confused scientists for decades. If life is common, where is everyone? Now that question is starting to evolve. Maybe we are not hearing nothing. Maybe we are just beginning to understand what we are hearing. This is where the story becomes even more interesting. Scientists are not suddenly claiming that aliens are visiting Earth. That is not what this is about. This is about something more subtle, more powerful, a shift in thinking, a slow realization that the universe may be more alive than we once believed. The language is changing. Words like impossible are disappearing. Words like unlikely are being replaced. Now you hear phrases like statistically probable. Increasing evidence, growing likelihood. That may sound small, but in science, that is a big shift because scientists do not change their language unless the data forces them to. And right now, the data is doing exactly that. In this video, you will see what changed. You will learn about the signals that scientists cannot fully explain, the objects that broke expectations, the planets that look too familiar, and the reason why some of the most respected minds in physics are no longer dismissing that for most of human history, Earth looked unique, a rare accident in a dark and empty universe. One planet with life, surrounded by silence. That idea is no longer holding up. In the last decade, astronomers have confirmed the existence of thousands of planets beyond our solar system. These are called exoplanets. Before the 19, not a single one was confirmed. Now the number keeps rising every year, quietly, steadily, almost like the universe is revealing them on a purpose. And here is where things start to feel different. Many of these planets are not random or extreme worlds. They sit in a very specific region around their stars, a narrow band where temperatures allow liquid water to exist, not too hot, not too cold. This region is known as the habitable zone. Water changes everything. On Earth, life exists wherever water exists. Deep oceans, frozen ice, underground reservoirs, even inside rocks, scientists now believe that if liquid water is present, life has a chance to begin. That means every planet in this zone becomes a candidate, not for advanced civilizations, but for something alive. That alone would be enough to raise eyebrows. But the discoveries did not stop there. The real shift began when scientists stopped just finding planets and started studying their atmospheres. That is a much harder task. These planets are incredibly far away. Some are hundreds of light years from Earth, yet new technology has made the impossible possible. One of the most powerful tools in the search is the James Webb Space Telescope. It does not take pictures in the usual way. Instead, it analyzes light that passes through a planet's atmosphere. That light carries a hidden signature, a chemical fingerprint, and those fingerprints are starting to reveal something unexpected. Scientists have detected water vapor in the atmospheres of distant planets, not traces, actual measurable amounts. In some cases, they have also found methane and carbon-based molecules. On Earth, methane is often produced by living organisms. It breaks down quickly in the atmosphere, which means something has to keep producing it. Seeing it elsewhere raises a serious question, because methane without life is possible. But methane with water, combined with certain atmospheric conditions, becomes harder to explain. One lesser known detail makes this even more interesting. Some of these planets orbit small, dim stars. These stars live much longer than our sun. That gives life more time to develop, billions of extra years. In theory, life on those planets could be far older than life on Earth. That changes the timeline completely. It means Earth may not be early, it may not be special. It may not even be average, it may just be one example among many. There are also planets called super-Earths. These are larger than Earth, but smaller than gas giants like Neptune. Some of them have thick atmospheres and stable climates, conditions that could support oceans, possibly even continents. And here's something most people do not hear. Some of these planets are relatively close in cosmic terms, just a few dozen light years away. That distance is enormous for humans, but in the scale of the galaxy, it is practically next door. Each new discovery adds pressure to an old belief, the belief that life is rare. Because the more habitable worlds we find, the harder it becomes to argue that life only happened once. And if life can begin in many places, then the next question becomes unavoidable. How far has it progressed on those worlds? That is where the signals start to matter. Space is not silent. It only feels that way because most signals are too faint, too fast, or too strange for human senses. But when scientists listen with the right instruments, they hear something very different. Bursts of energy, sharp flashes, patterns that appear, disappear, and sometimes return. One of the most mysterious discoveries in recent years is known as fast radio bursts. These are extremely powerful pulses of radio waves coming from deep space. Each burst lasts only a fraction of a second. Yet in that brief moment, it can release more energy than the sun emits in days. At first, they looked like random noise. One-time events, impossible to track, then something changed. Some of these bursts started repeating. That detail caught attention immediately because random cosmic explosions do not usually repeat in the same way. When a star explodes, it is gone. When a black hole consumes matter, the signal fades, but these bursts were coming back again and again from the same location. That raises a difficult question. What kind of source can produce such powerful energy repeatedly without destroying itself? Scientists have proposed explanations. Highly magnetized neutron stars, known as magnetars, are one possibility. They can release enormous energy in short bursts. But even that explanation does not fully account for the precision and timing seen in some signals. Because some bursts are not just repeating, they are structured. There are patterns, intervals that are not perfectly random, frequencies that shift in ways that seem almost organized. Not clearly artificial, but not entirely chaotic either. And then there is a signal that still stands apart from all the others. In 1977, a radio telescope picked up a strong narrowband signal that lasted for 72 seconds. It came from the direction of the constellation Sagittarius. The signal was so unusual that the astronomer reviewing the data circled it and wrote one word next to it. Wow. That moment gave the signal its name, the WOW signal. It has never been detected again. Despite decades of searching, scanning the same region of space using more advanced equipment, nothing identical has returned. That makes it even more difficult to explain. A one-time event with characteristics that do not easily match known natural sources. Some scientists believe it could have been a rare cosmic event. Others remain uncertain because the signal had a frequency that falls within a range often considered ideal for interstellar communication. Quiet, clean, less interference. That detail is rarely discussed outside scientific circles. There are also signals that seem to drift in frequency over time. This is known as a Doppler shift. It can indicate movement. Either the source is moving or the signal itself is changing in a controlled way. Both possibilities are intriguing. Still, scientists remain careful. No one is claiming that these signals are proof of intelligent life. That would require clear, repeatable evidence. Something unmistakable, something beyond doubt. But the tone is shifting. Instead of dismissing these signals, researchers are cataloging them, studying them, comparing patterns, looking for consistency, because the more data they collect, the harder it becomes to treat all of it as coincidence. Each new signal adds another piece to a puzzle that no one fully understands. And sometimes the mystery is not just in what we hear, it is in what passes through our own cosmic backyard without making a sound. In 2017, something entered our solar system that should not have been there. It did not come from a known orbit. It did not belong to any familiar class of objects. It arrived from deep interstellar space, moving at a speed that made one thing clear: this object was not born here. Astronomers detected it late. By the time they noticed it, it was already on its way out. There was only a short window to study it. Every second mattered. They named it Oumuamua. At first, it looked like a comet. That was the safest assumption. Comets are common. They carry ice and dust. When they get close to the sun, the heat causes their surface to release gas. That creates a visible tail and a small push that slightly changes their motion. But this object did not behave like a normal comet. It had no visible tail, no cloud of gas, no dust trail, nothing that telescopes could clearly detect. Yet something strange was happening. As it moved away from the sun, it began to accelerate, not slow down, not drift. Accelerate, that detail confused scientists immediately because acceleration requires force. And in space, that force has to come from somewhere. For comets, the explanation is simple: outgassing. Gas escaping from the surface acts like a tiny engine. But here, there was no clear sign of outgassing, no gas, no tail, no visible activity. That left scientists with a problem. If it was not a comet, then what was it? Some researchers suggested it could be made of unusual materials: hydrogen ice, nitrogen ice, substances that are harder to detect because they do not leave obvious traces. These ideas tried to explain the missing evidence while keeping the object within known physics. But not everyone agreed. A small number of scientists proposed something far more controversial. They suggested that the object might not be natural at all, that its shape, motion, and acceleration could point to something artificial. Perhaps a thin structure, possibly even something like a light sail pushed by radiation from the sun. That idea sparked intense debate. Most scientists rejected it, not because it was impossible, but because there was not enough evidence to support such a claim. Science requires proof. Strong, repeatable proof. And in this case, the data was limited. The object was already gone. Still, the question remained because even the natural explanations had gaps. One lesser-known detail adds to the mystery. The object showed extreme brightness variations as it rotated. This suggested an unusual shape, possibly very long and thin, or very flat. Either form is rare for natural space objects. Most asteroids and comets are more irregular, not so extreme in proportion. That made the object even harder to classify. Then there is the origin. Its trajectory showed that it came from outside our solar system, not from the distant edges like the Oort cloud, but from another star system entirely. It traveled for millions, possibly billions of years before passing through our neighborhood. And then it left, no warning, no return. Since then, scientists have detected at least one more interstellar object passing through. That suggests these visitors may not be as rare as once thought. They may pass through our solar system more often than we notice, which leads to a deeper concern. If objects like this can enter and leave without clear detection, how many have already passed by unnoticed? And how many of them behaved in ways that we still do not understand? For years, reports of strange objects in the sky were pushed aside. Pilots saw them, radar systems tracked them, witnesses described them in detail, but the official response stayed the same: ignore, deny, Move on. That response has started to change. Governments have begun releasing information that was once locked away. Not rumors, not secondhand stories, actual reports, recorded encounters, data collected by military systems. These documents describe objects that do not behave like known aircraft. The language used in these reports is careful, very controlled. The term UFO has been replaced with something more neutral, unidentified aerial phenomena, UAP. That shift in wording matters. It removes assumptions. It focuses on observation, not interpretation. It allows scientists and officials to study these objects without immediately jumping to conclusions. Both NASA and Pentagon have acknowledged that these phenomena are real, not illusions, not equipment errors, real objects tracked across multiple sensors. That alone is a major change because it confirms that something is there. Some of the most detailed encounters come from trained military pilots. These are individuals who understand flight, speed, and distance better than most people. They are not easily confused. Yet even they describe movements that do not make sense, objects that accelerate without visible propulsion, objects that change direction instantly without slowing down, objects that hover in place then vanish at extreme speeds. These are not small differences. They go beyond the limits of known technology. Human aircraft cannot withstand such forces. The physics would tear them apart. The pilots inside would not survive. One lesser-known detail makes this even more striking. Some of these objects were detected not just visually, but through infrared sensors and radar at the same time. That means they were not optical illusions, not reflections. They have physical presence, heat signatures, movement patterns. Multiple systems confirm the same object. That reduces the chance of error. There are also reports of objects entering the ocean without slowing down, moving from air to water in ways that defy known engineering limits. No splash, no visible resistance, just smooth continuous motion. That behavior is still not fully explained. Scientists have proposed possibilities, advanced human technology, unknown atmospheric effects, instrument glitches. Each explanation tries to fit the data into known frameworks, but none of them fully explain everything. And this is where the shift becomes clear. Instead of dismissing these events, scientists are now studying them carefully, systematically. Papers are being written, data is being analyzed, discussions are happening in serious academic settings. This was not the case before. In the past, studying such topics could damage a scientist's reputation. It was seen as unprofessional, risky, now that stigma is fading slowly but steadily because the evidence has reached a point where ignoring it is no longer an option. That does not mean scientists are claiming these objects are extraterrestrial. That conclusion requires far more proof. But it does mean one thing. There are objects in our skies that we do not understand. And the more closely they are studied, the more complex they appear, which brings the focus back to a deeper question. If these phenomena are real, and if they show capabilities beyond current human technology, then their origin becomes the next mystery to solve. The universe is vast beyond comprehension. Hundreds of billions of galaxies, each filled with billions of stars. Around many of those stars, planets are forming, evolving, changing over time. By simple numbers, life should not be rare. That is where the problem begins. Because when scientists look out into space, they do not see clear signs of intelligent civilizations. No confirmed signals, no undeniable structures, no direct contact, just silence. This contradiction has a name, the Fermi paradox. It comes from a simple idea. If the universe is so large and if life has had billions of years to develop, then advanced civilizations should exist. Some of them should be far older than humanity, far more advanced, capable of spreading across star systems, and yet nothing obvious has been found. No ships, no clay. Ear messages, no confirmed presence. That silence is not comforting. It is confusing because it suggests that something is missing in our understanding. One possible explanation is that intelligent life is extremely rare. Life may begin often, but it may not survive long enough to become advanced. Planets may lose their atmospheres. Stars may become unstable. Civilizations may destroy themselves before reaching the stars. That would mean humanity is unusual, not because life is impossible, but because survival is difficult. Another possibility is distance. The galaxy is enormous. Even if intelligent life exists, it may be too far away for signals to reach us clearly. Radio waves weaken over distance, signals spread out. By the time they arrive, they may be too faint to detect, or they may arrive millions of years after they were sent. In that case, the silence is not real, it is a delay. There is also a more unsettling idea. Advanced civilizations may choose not to reveal themselves. They may observe from a distance, quietly, without interference. This concept is sometimes compared to a form of cosmic isolation, a rule that prevents contact with less developed species, not out of fear, but out of caution. One lesser-known theory suggests that truly advanced civilizations may not rely on signals we can detect. They may use forms of communication beyond radio waves, methods that are faster, more efficient, or entirely unknown to current science. If that is true, then humanity may be listening in the wrong way. There is another detail that makes the silence even more strange: the age of the universe. Our galaxy formed billions of years before Earth. That means if intelligent life developed elsewhere, it could be millions or even billions of years ahead of us. With that kind of time, even slow expansion across space would eventually cover large regions of the galaxy. Yet there is no clear sign of such expansion, no large-scale structures, no visible changes to stars that would suggest advanced engineering, at least none that have been confirmed. This leads to a quiet but powerful idea. The signals may already be around us, not loud, not obvious, but subtle, hidden within data, mixed with natural noise, waiting to be understood. Because as detection methods improve, small anomalies start to stand out. Patterns that were once ignored begin to gain attention. Signals that seemed random begin to show structure, which raises a deeper possibility. The silence may not be empty. It may be misunderstood. The change did not happen in a single moment. There was no announcement, no sudden discovery that forced the world to react. Instead, the shift began quietly inside data sets, research papers, and conversations that most people never hear. Year after year, more information started to build. More planets were discovered. More signals were recorded. More anomalies appeared in places where nothing unusual was expected. Each one on its own was not enough to prove anything, but together they began to form a pattern. Scientists started to notice that pattern. At first, the response was cautious. It always is. Science moves slowly for a reason. Claims must be tested. Results must be repeated. Every possibility must be examined before any conclusion is accepted. But there comes a point when the amount of data becomes too large to ignore. That point is getting closer. Researchers are now more willing to discuss ideas that were once avoided, not because they have abandoned skepticism, but because the evidence has expanded the boundaries of what is considered reasonable. This is where voices like Brian Greene become important. He does not claim that alien life has been found. He does not make extreme statements. Instead, he focuses on probability, on the mathematics of the universe, on the sheer number of stars, planets, and conditions that could support life. When those numbers are considered, the idea that life exists elsewhere stops being unlikely. It starts to look expected. That is a major shift. The conversation is no longer about belief. It is no longer about opinion or speculation. It is about evidence-based possibility, about following the data even when it leads to uncomfortable questions. One lesser-known detail highlights this change. In the past, scientific papers rarely mentioned intelligent life unless there was strong evidence. Now, more studies include it as a possible explanation, even if it is listed alongside natural causes. That may seem small, but it reflects a growing openness. Another change is happening in public institutions. Agencies that once avoided the topic are now funding research into unexplained phenomena. Universities are creating programs to study astrobiology, the search for life beyond Earth. Conferences are being held where scientists openly discuss signals, planetary chemistry, and the limits of detection. This was not common before. The stigma is fading. That does not mean the mystery is solved. There is still no confirmed proof of alien life, no verified signal that can be clearly traced to an intelligent source, no direct contact. But the direction of the evidence is becoming harder to dismiss. Signals are becoming more frequent. Observations are becoming more precise. Technology is improving at a rapid pace. Each new tool reveals more detail, more complexity, more questions. And those questions are no longer being pushed aside. They are being studied carefully, systematically, with increasing attention. Because something is changing, not just in space, but in the way humanity looks at it. The idea of alien life is no longer confined to science fiction. It is no longer treated as a fringe concept. It is moving into the center of scientific discussion, and as that shift continues, the line between possibility and reality begins to blur. Something has changed. For a long time, humanity was searching in the dark, guessing, hoping, waiting for a sign that might never come. That phase is ending. Now the universe is starting to respond, not with clear answers, not with direct contact, but with hints. Small signals, strange patterns, objects that do not behave the way they should, planets that look more familiar than expected. Each piece on its own is uncertain. Together, they point in one direction. We are not alone in a quiet, empty universe. We are inside a system that is far more active than we once believed. The biggest shift is not in the sky, it is in the question itself. It is no longer about whether life exists somewhere out there. The scale of the universe makes it almost unavoidable. The real question now is distance. How far away is it? And more importantly, how close? Because the closer it is, the more it changes everything. It changes how we see our planet, our history, our future. It forces humanity to face something it has never faced before, the possibility that we are not the only intelligence in this vast system, and we may not be as isolated as we think. The next discovery might not come with a warning. It might arrive quietly, a signal that stands out just enough, a pattern that repeats one too many times, a piece of data that refuses to fit any known explanation. And when that moment comes, it will not just be another scientific finding. It will redefine our place in the universe. If this journey into the unknown interests you, if you want to explore more of these mysteries and stay ahead of discoveries that could reshape everything, take a moment to support the channel, like the video, subscribe, stay connected, because the story is still unfolding and the next piece of evidence might be closer than anyone expects.